So I want to talk a little bit more about 7.3. We'll talk about this in class, but so that you can have a preview. The ellipse is the topic of 7.3, and as with the parabolas that we talked about in 7.2, we're first going to have the important point of the center. It was the vertex for the parabola, but for the ellipse it will be the center will be at the origin, and then we'll let the center move to the point h, comma, k. So there's two styles of ellipses. And let me just write them both the same way like this, where you have x squared over heart squared plus y squared over flower squared equals 1. So my point in doing this is to get you away from this a and b and that it matters which one is which, because it really doesn't matter. All this tells you is that in the x direction you go heart and negative heart, and in the y direction you go flower and negative flower. And that's how you draw your ellipse. And it just depends. If the hearts are bigger, then the ellipse is this shape. So this is if the hearts are smaller, the hearts are bigger than the flowers, sorry. Then this way is the y direction, the flowers are bigger than the hearts. So it's still heart and negative heart in the x direction, and flowers and negative flowers in the y direction. So it's the number under the y that says how long the ellipse is in the vertical direction. And the number that's squared under the x squared term tells you how wide the ellipse is in the horizontal direction. Now, ellipse also has special points called focus points. There's two of them. So the plural is F-O-C-I, which you can either say foci or foci. Both are correct. So there's a special relationship between these denominators and the distance from the center to the focus point. So this distance is called c. And if I find the difference in the denominators in absolute value, so whichever one is bigger, subtract that direction, and that's going to give you c squared. So if the flowers are bigger, do flower squared minus heart squared. If the hearts are bigger, do heart squared minus flower squared. So it's the difference of the denominators, and the square root of that will tell you the distance from the center to the focus point. So let's analyze an equation of an ellipse, and that will mean to find the center, the major axis, which is which way is it longer. For this type of ellipse, the major axis is horizontal. Find the foci, the two focus points, and the vertices of the ellipse. So the ellipse has two vertices on the long ends. So this is a vertex and this is a vertex. This is a vertex and this is a vertex. This point is not a vertex. This is not a vertex, not a vertex, and not a vertex. So they're points that help us draw the ellipse, but they don't have a special name. They're not vertices. So this question says, let's find the vertices and foci of this ellipse. So we're going to look under the x squared term, and we see a 9. So we need the square root of that, so it's plus or minus 3. So there's 2 points that are on our ellipse. Then we look under the y squared term, and we see a 4. So the square root of that is plus or minus 2. So again, these are points that are on the ellipse. Well, now that we've plotted these points, we can see which way it's larger. So we can see that it's larger in the horizontal direction. The center, that's easy because this one is still not moved around, so the center is the origin. The major axis is the x-axis. If the ellipse moves around, it might not be an axis. So we need to find the focus points. So the difference in these two denominators is 9 minus 4, or 5. And that equals c squared, so that means c equals plus or minus the square root of 5. So that's between 2 and 3, right? A little closer to 2 than to 3, because 2 squared is 4, 3 squared is 9. So it's a little more than 2. So we go a little more than 2, and here's a focus point. A little more than 2, and here's a focus point. This is a vertex, and this is a vertex. So the vertices are going to be negative 3, 0, and 3, 0. The foci of the ellipse are going to be root 5, 0, and negative root 5, 0. So those are going to be the focus points or the foci. So we found the center. That was 0, 0. We found the major axis was the x-axis, found the foci, and found the vertices, and graphed the ellipse. Don't forget to label your axes. Okay, so this next type of problem says find an equation for the ellipse and then graph the equation. So I'm going to start with drawing the picture and say, well, the center's at the origin to make it easier for me. One focus is at negative 1, 0. That's not right. Negative 1, 0. There we go. Okay, so then a vertex is at 3, 0. So this is a vertex and this is a focus. Negative 1, 0. So because of all the symmetry of the ellipse, we know there's also a focus at 1, 0. So if there's a focus at negative 1, 0 and the center's at the origin, by symmetry we know there's another focus at 1, 0. And then if we have one vertex at 3, 0, the symmetry of the ellipse tells me I'll also have another vertex at negative 3, 0. 1, 2, 3. So we know we have the symmetry of the ellipse working for us here. So I know I have x squared over 9, I got that part. Y squared over, I don't know what, equals 1. But I can see that it's longer in the x direction. So I know that 9 minus whatever that question mark is has to equal c, the distance from the center to the focus, squared. So this is c squared. This is the difference of denominators. So can you see that the question mark unknown quantity must be 8? Let's make sure that makes sense to you. So my equation of my ellipse is x squared over 9 plus y squared over 8 equals 1. So the difference in the denominators is 1. That's the distance from the center to the focus. So then under the y, I have plus or minus 2 root 2. So that's going to be about 2.8 or so. We know it's less than 3. So we'll just estimate it here. Make sure it's symmetric though, and then draw the ellipse on your graph. Okay, so this is the other type of ellipse, but it's really not different. It's still going to have an equation of x squared over a squared number plus y squared over a squared number equals 1, where the number under the x says go plus or minus b in the horizontal direction. The number under the y says go plus or minus a in the vertical direction. Okay, so here we have graph the equation. Oh my gosh, it doesn't look like the standard form yet. I have a 36 over here. So the very first thing I need to do is divide both sides by 36 because I've got to have that 1 on the right-hand side. So I'm going to have y squared over 9 plus x squared over 4 equals 1. So that tells me in the y direction, I'm going to go 3 and negative 3 from the center at the origin. X plus or minus 2. So I can see this one is larger in the vertical direction. Not a lot larger, but a little bit larger. So this point is a vertex and this point is a vertex. The points on the x-axis are not vertices. They're just points that help us draw the ellipse. So the vertices are going to be 0, 3 and 0, negative 3. And now we need to find the foci. So the difference of denominators is 9 minus 4, so that's 5, and that equals c squared. So that means c equals plus or minus root 5. So that means we go in the direction of the vertex a little more than 2 and get a focus point. Same amount in the other direction and get the other focus point. So we can see that the focus points are going to be 0, root 5, and 0, comma, negative root 5. And then we've already graphed the equation. Okay, let's look at another example where it says find an equation for the ellipse where the center's at 0, 0, focus at 0, 1, so here's a focus point, vertex at 0, negative 2. So here's a vertex. So we also know there will be a vertex in the mirror image spot and a focus in the mirror image spot. So we can tell that already under the y squared term, we're going to have 4 because we have 1, 2, square that, that's 4. We have x squared over, we're not quite sure what yet. But we can see that because the vertices and the focus line up, you have vertex, focus, center, focus, vertex. That's always going to be the pattern for the ellipse. Vertex, focus, center, focus, vertex. So I can see it's going to be bigger in the y direction, so the number under the y is going to be bigger. So I should do the difference as 4 minus the number I don't know. And that's going to equal c squared. Well, c is this distance from the center to the focus, so that's 1. So the number I don't know is 3. So it looks like it's going to be x squared over 3 plus y squared over 4 equals 1. So I need to go root 3. That's about 1.7 in the x direction. So you can see you're going to be estimating a little bit on some of these points. And there's my graph of the equation. Okay, so now we're going to let the center move to the point HK. The nice thing is all the learning you did with parabolas follows here and works in the very same way. It's x minus h shifts h to the right. So if you have a plus, it means you went left. And you have y minus k shifts k up. So if you have a plus, it means you went downward. So here's a couple of ellipses. Let's see if we can write the equation for the ellipse. So this first one, we have the center is at negative 1, negative 1. So I'm going to have x plus 1 quantity squared over something plus y minus negative 1. So y plus 1 over something. And that's going to equal 1. Well, I can see that the distance from the center to the edge is 1 in the x direction. So I need a 1 squared under the x term. And then I can see in the y direction, it's 1, 2. So under the y term, I need a 4 for 2 squared. So I have x plus 1 squared. We don't really need to show divided by 1. Plus y plus 1 squared over 4 equals 1. And I would double check and just make sure the point negative 1, 1 made the equation true. And it looks like it does. So now number 42, I have the center is at 0, 1. So I'm going to have x minus the 0 quantity squared over something plus y minus 1 quantity squared over something equals 1. Well, now I can see in the x direction horizontally I have 2 from the center to the edge, so that makes a 4 under the x term, and 1 in the vertical direction under the y. We're going to have a 1 squared, so that will just be 1. So I have x squared over 4 plus y minus 1 squared, and I don't need to write the divided by 1, and then that equals 1. And so again, I would make sure that the point 2, 1 made my equation true so that I feel comfortable that my equation is correct. Looks like it works. Okay, so then here is analyze the equation to find the center, foci, and vertices of each ellipse. So this first one, we can see under the x term we have plus or minus 3, under the y term plus or minus 2. You're looking at the square root of that number. The center we can read from the equation is negative 4, negative 2. So I start by drawing my picture, negative 4, negative 2. And then in the x direction, I'm going to go 1, 2, 3. And in the y direction, the other x direction, 1, 2, 3. And then in the y direction, up 2 and down 2. Not sure what happened here. Let me see if I can get rid of this.